So what we are going to see in this part 2 is that we are going to see the mobile phone evolution or the overview of wireless standards, which is the first generation. Example is your AMPS. Second generation, example is your GSM IS95. Third generation, UMTS, WCDMA, CDMA 2000. Fourth generation, the LTE advanced versions. So these are the 4 different generations being available. So let us start with the list of systems which were being evolved. Since the mid 1990s, the cellular communication industry has witnessed explosive growth. The wireless communication networks or the mobile communication networks have become much more pervasive than anyone could have imagined when the cellular concept, which was first developed during the 1960s. So the number of individual subscribers from 1960s to 1970s to 1980s, then till 2001, the growth of the cellular systems or the mobile phone systems was very much lesser. So after 2001, the number of individual subscribers was increased tremendously. Most countries throughout the world continue to experience cellular subscription with an increase of 40 percentage or more for every year. Every year there was addition of more cellular subscribers, which is mobile phone users. So after 2006, the widespread adaptation of mobile communications was accelerated by most of the governments throughout the world with an increased competition and new radio spectrum licenses for personal communication systems. So for this, they use the frequency band 1800 to 2000 megahertz frequency band. So this was the frequency band used, which came under personal communication systems, PCS. So the rapid growth in the cellular telephone subscribers has demonstrated conclusively that the mobile communication is a robust, viable voice and data transport mechanism. The widespread success of these mobiles has led to the development of newer wireless systems and standards for many other types of telecommunication traffic besides the mobile voice telephone calls. So these are some of the examples of the cellular network standards, right from first generation to the proposed fifth generation. So let us see each and every systems one by one. The first generation system included the AMPS, Advanced Mobile Phone Service System, where the transmission of signals were being done through cabled wires. And with the help of TACS, which is Total Access Communication Systems, and the ETACS, Extended Total Access Communication System, the first generation mobiles were being developed, mostly in Northern America. So this AMPS was very much popular. So then the second generation mobiles, which we called as 2G, Most of the uh, users during 2005 to 2008, 9, 10, 11, those who were having mobile phones, they were experiencing second generation mobile phones, and still now it is in usage. Even some people use 2G cellular network standards. So the 2G technologies which conform to the second generation cellular networks was unlike the first one, because the first generation relied on a technique called FDMA FTD, frequency division multiple access frequency division duplexing, FDD. Whereas the second generation standards like GSM, 3GPP, AMPS, the second generation used TDMA FDD, time division multiple access frequency division duplexing. This methodology was being used in GSM, whereas in 3GPP2, the CDMA FDD was being used, code division multiple access frequency division duplexing. Multiple access systems was being used. So the most popular second generation standards had three different TDMA standards. One is the global system for mobile, GSM. Second one is the CDMA, code division multiple access. Third one is the NADC, which is not given here. NADC, North American Digital Cellular Systems. So each and every system supported different kinds of formats, different communication in different parts of the world. So especially the NADC, North American Digital Cellular System, used IS 136, Interium Standard 136, which was used in North America, South America, and Australia, using the PCS bands, personal communication system bands. Whereas the uh, CDMA system, which is IS 95, Interium Standard 95 CDMA system, was popularly called as the CDMA 1. CDMA 1. So this was being used by the Japanese people, Japanese people by as Pacific Digital Cellular Systems, PDC. So these were the uh, different types of standards being used in second generation mobile systems. So this second generation standards mentioned here represented the first set of wireless air interface to rely on digital modulation and sophisticated digital signal processing techniques, which is present in the handsets. AMPS was fixed in all the places. AMPS was fixed, whereas in the AMPS was fixed in the first generation, whereas in the second generation, most of the users were in motion, so mobile. So the second generation was first introduced during 1990s. The examples that I had said, AMPS, EDC, CDMA1 are all the examples. So all these provided a different type of area coverage, with specific channels and specific bands. In many countries, in many countries, 2G wireless standards were designed and deployed for conventional mobile phone telephone service, which was used as a high capacity replacement, replacing the existing first generation cellular phones. So these are some of the examples of the second generation. An example is the GSM, Global System for Mobile Communication. Second generation mobile cellular phone digital system. It was introduced during 1990s in Finland. This was the first country to introduce. Now it was being operated then by over 219 countries and its territories. The modern mobile systems are also being installed to provide fixed, which is non-mobile telephone service to different residential purposes, businesses in developing nations. This is particularly cost effective for providing plain old telephone service in the countries, replacing the existing landline telephone system. This was being developed. Since all the second generation technologies offered at least 3 times increase in spectrum efficiency as compared to the first generation. As compared to the first generation, the second generation provided 3 times increase in spectrum efficiency. So everybody moved from first generation to second generation. Due to its rapid growing customer base, as well as the ongoing change out of analog to digital 2G technologies, where first generation was dealing only with analogic. You can see that was analogic, whereas second generation was shifting towards digitalization. So this digitalization took place during 2001 in United States and parallel in Japan by AT&T Laboratories in US and NTT Technologies in Japan. They decided to what to call, remove or abandon the IS 135 Interim Standard 136, not 135, 136 Interim Standard 136, and in US and PDC in NTT. So by doing this, what they have done is that they switched from FDMA to TDMA, okay, because they were using FDMA in those versions. Then from FDMA to TDMA they shifted. Meaning is that it gives this TDMA which was utilized or imposed on the second generation led to some advantages in terms of bandwidth, in terms of moving or shifting from voice to text, text to multimedia services such as audio, video, MMS, internet on the same technology. So this led to the development of the third generation systems. Third generation. So this was not directly converted to third generation due to its limitations in the technology front. So they had developed a 2.5G, which is 2.5 generation mobile radio network, which was developed during 1990s. In 1990s, the second generation digital standards have been widely deployed by wireless carriers for mobile and PCS. Even though these standards were designed before the widespread use of the internet, because in 1990s internet was not much in usage. So later it came into existence. So consequently, 2G technologies used what do you call circuit switched data modems, circuit switching that limited the data users to use single circuit switched voice channel. Only voice channel was enabled in the second generation mobiles. Then the data transmission in second generation were generally limited to the data throughput or the data rate of an individual user. So subsequently, in 2001, the entity Docomo, which was operating in Japan, and this IS, so AT&T Wireless, operating in US, came to an conclusion or came to an MOU such that they should discontinue the existing FDMA such that they can move on to another type of services in addition to voice, which were internet service. So during 2001, the SMS was not being spread out widely in worldwide. So after 2001, 2002, there was a greater development. So SMS short message service was being introduced, which is the future of your 2.5G systems. So in an effort to retrofit the second generations for compatibility with the increased throughput data rates, which requires support of modern internet applications, the new data centric standards has been developed that were imposed on existing 2G mobiles or the 2G systems. So which we call it as 2.5 technology. I'll show you the slides on 2.5 technology also, because we need to move on to third generation, because it's first generation, second generation, it comes third generation. In between there is a generation called 2.5. Okay, why it came, I need to say you. So that's what. Later the 2.5 technologies supported a popular new web browsing format language, which was called as WAP, Wireless Application Protocol, which allows the standard web pages, www dot web pages, which were available on PCs or laptops, can be accessed in mobile phones. So the wireless application protocols were being designed such that they can be brought up into these small handy phones, portable wireless devices. So as of late 2001, the Docomo, which was using PDC, personal digital communication, had a data transmission of about 9.6 kilobits per second in Japan. In Japan, I'm telling you, in 2.5 generation system. So it was supporting a wireless web access for over 25 million subscribers in its country. So the approximate uh, usage per day was around 10 million subscribers using the network. in Japan. So the appropriate 2.5 upgrade path for a particular wireless carrier was originated only from the second generation. So the evolution of the 2.5G standard, which used TDMA systems, are some of the examples that I'm going to give you now. So the first example of the 2.5G TDMA standards that was being evolved on GSM carriers is that GPRS, General Packet Radio Service. Having here. And high speed circuit switched data. So the application is HSDPA, high speed downlink packet access. This is an example of that. Third one is the enhanced data rate for third one is the enhanced data rate for GSM evolution, which is Edge. Which is Edge we call in short as. So these three were the best examples of 2.5G TDMA systems that was being developed as an advancement towards third generation. So still we are using GPRS as a future of our mobile, which we are using for fourth generation, or the Android phones. This is GPRS. So General Packet Radio Service, where we get the internets. So coming to the 2.5G standards for CDMA. So Edge is the best example. So whereas when you go for GSM, it is the high speed downlink packet access is the example of 2.5G, which using TDMA, and the GPRS, General Packet Radio Service, is the examples. Whereas for CDMA system, which is IS 136, Interior Standard 136 was being developed, Edge is the best example. So there are different types of coding mechanisms were being used, multiple or modulation coding schemes was being deployed where it used PSKs, BPSK, 16-bit PSK, 8-bit PSK, 64-bit PSK and all. So that was being done on Edge. But due to some of the disadvantages, this 2.5G could not provide the desired data rate depending upon the geographical areas. So then this 2.5G was developed into the third generation standards. So it's been in existence during 2001. So the third generation systems provided unparalleled wireless access that have been never been given before. So it had given a best feature named VoIP, Voice over Internet Protocol. Voice over Internet Protocol feature voice activated calls, internet access, unparalleled network capacity in a same handheld devices. So all these features in a single handheld devices was being provided by the third generation, which we call it as 3GPP, third generation partnership project. This was divided into three project releases: 3GPP, 3GPP2, 3GPP3. These 3GPP is a joint venture of North America, France, Korea, as well as Japan. So the companies that developed the 3G equipment had the ability to receive live music, conduct interactive web sessions, and have simultaneous voice and data access with multiple parties at the same time using a single mobile phone, whether the user is walking, driving, sitting, standing, or moving in an office. This was the service being offered. The ITU, which we call it as International Telecommunication Union, formulated a plan to implement a global frequency band during 2000. Sorry, during the year 2001, with an operating global frequency of about 2000 megahertz that would support a single ubiquitous wireless communication for all countries throughout the world. So this is what 3GPP project is. The combination of most of the countries came for developing 3G standards. So this plan is called as IMT, International Mobile Telephone 2000. So this was successful after the Y2K problem in helping to cultivate, debate, and technical analysis for a new high-speed mobile telephone solutions as compared to the existing 2G, because 2G was in existence. So in order to provide better services than 2G, they had made a consortium and they developed it. The third generation evolution for CDMA systems led to CDMA 2000. CDMA 2000. There are several variants of CDMA 2000 which are being currently developed based upon the Interium Standard 95 and Interium Standard 136. And based on GSM also. The eventual third generation evolution for GSM IS 136 and PDC system led to the development of wideband CDMA, WCDMA, which is called as UMTS, UMTS, Universal Mobile Telecommunication Service for higher data speeds and capacity. So this WCDMA is based on the network fundamentals of GSM as well as the merged versions of GSM and IS-135 through the edge technology. Combination of GSM as well as AS136 with Edge from 2.5G. So it is to say that the two major technologies were the CDMA 2000 and WCDMA, the third generation systems. So now next let us see about the frequency bands that were being permitted for the usage of this WCDMA and CDMA 2000s. The commercial usage of CDMA or the third generation equipment came into existence in 2001 during sorry in Japan. In Japan, it was there that the first commercial third generation was being deployed. The IMT 2000 was a standard organization that was currently separated into two major things. One is the third generation partnership project for wideband CDMA and separately for IS 136. So the countries throughout the world were currently determining new radio spectrum bands to accommodate the third generation networks that were likely to be deployed during 2004 to 2005, during 2001. So the International Telecommunication Union, ITU, in the World Radio Conference 2000, year 2000, World Radio Conference established the 2500 to 2690 megahertz frequency, 1710 to 1885 megahertz frequency, and 806 to 960 megahertz frequency bands for the usage of third generation mobiles. So which gave us a peak data rate of 3.1 megabits per second in downlink and 1.8 megabits per second in the uplink. So any queries till this, till the third generation? I have a few more points to be discussed on third generation also. So any queries in 1G, 2G or 3G till now? If there is anything, put in chat box. So since there were no queries in the chat box, I proceed on to the next topic called the third generations. So still now which we had seen is introduction to third generation. So the Universal Mobile Telecommunication System, which is UMTS, is the third generation WCDMA, wideband code division multiple access. So the European countries were in much eager to develop this uh, UMTS right from 1996. So they had formed a standard called European Telecommunication Standards Institute (ETSI), such that the manufacturers, government regulators, developers were on the vision to implement UMTS as a competitive open air interface for the third generation telecommunication systems. This UMTS was submitted I'll tell you. The UMTS was submitted by the European Telecommunication Standards Institute (ETSI) to the International Telecommunication Union, that is the IMT body, International Mobile Telecommunications 2000, to consider this UMTS as a world standard in order to improve the higher data rate and in order to give high capacity upgrade for the existing GSM. So around the century passed, the WCDMA, which is UMTS, was competing with several different standards. And all the proposals were merged together, and it was finally given as WCDMA. So this WCDMA is now called as UMTS. So the back end of this UMTS is that it consists of GSM, Global System for Mobile, IS 136, Interior Standard 136, and PDC TDMA technologies with 2.5G TDMA technology. Combination of this. So the advantages and applications of WCDMA is that this WCDMA supported a packet data rate of up to 2.048 megabits per second for every user, approximately 2 megabits per second for every user if the users were in stationary, that is fixed, not in motion. So which provided a high quality data, multimedia services, live streaming audio, live streaming video, broadcasting type of services to consumers or the customers. So this UMTS could support in excess of 8 Mbps in its future versions. So the WCDMA provided a public and private features such as video conferencing, virtual home entertainment, broadcasting, m-commerce, mobile commerce, games, interactive videos, virtual private networking throughout the world. It was the special features of UMTS. So this UMTS required a minimal spectrum allocation of just 5 megahertz, which is an important distinction of this UMTS with respect to the other standards. This minimum spectrum allocation of 5 megahertz radio channel supported about 100 to 350 simultaneous voice calls at a time. At a time, around 100 to 350 voice calls can be made simultaneously, which was a greater advantage in the 3G systems. So, which was dependent on the type of antenna being used, antenna sectoring, propagation conditions, user velocity, and antenna polarizations. This WCDMA employed a variable direct spread spectrum technology with a chip rate of 16 mega chips, 16 mega chips per second for every user. For every user, the CDMA gave 16 mega chips, which is 16 to 10 power 6 chips per every second for every customers. So the common rule for the WCDMA is that it will provide at least a 6 times increase in spectral efficiency over the GSM, which was in existing during 2006. Due to the expensive baseband station equipment installation, the WCDMA was very much slower throughout the world. So thus, the evolutionary path of 3G required a dual mode or a tri-mode cellular technologies that can automatically switch between the 2G TDMA and the edge or the WCDMA. So by 2015 or 2016, the WCDMA was fully installed, and now which we are using is the switching mode of operation, which is called as the fourth generation mobiles, which is VoLTE, voice over long term evolution, VoLTE. So the drawbacks in the third generation was overcome, which is the switching of systems, switching from 2G to 4G, or switching from higher standards to the lower standards was a big task in the WCDMA, which is being overcome nowadays, and we are using it in 4G. So next is the enhanced DOREVA, okay. Enhanced access for higher data rate. So this was evolved from CDMA 1 technology, which gave to CDMA 2000. So if you are seeing now, that's in the WCDMA we had completed. Now we have to see CDMA 2000. So this CDMA 2000 version was evolved from CDMA 2000 and CDMA 1. So this is a technology which was built by the second generation on a 2.5G CDMA technology. This was evolved by Hong Kong. The country Hong Kong was developing this CDMA 2000. It used 144 kilobits per second for every users. For every user, the data rate was provided was around 144 kilobits per second in CDMA 2000, first version. And in the subsequent versions, it was enhanced CDMA 1 version, CDMA 2 version, CDMA 3 version in terms of CDMA 2000. So the CDMA 2001 version EV, we call it as CDMA 2001 EV. So EV represents a revolutionary advancement. EV, evolutionary advancement. CDMA originally was developed by a country called Qualcomm. Qualcomm was doing this research in order to provide a high data rate or high packet rate with the existing IS-95 and IS-95B and the CDMA 2000 networks. So this CDMA 1 enhanced advancement provided a data rate of around 2.4 megabits per second for every users, which was used in a high speed packet access, HSPAs. So if you have used BSNL modems some 10 years back, you would have experienced that HSPA, HSPDAs, which were operating on third generations. So then the evolutionary took place. The bandwidth and the higher data rate was required. So they had shifted to um, CDMA 2000 enhanced version of 3. So this enhanced version of 3 provided more spectral efficiency as compared to the 1 version and 2 version, where it used multi-carrier techniques to adjust one channel with the second channel for increased bandwidth. The CDMA 2000 third version used users with 3 adjacent 1.2 megahertz radio frequencies throughout throughout the entire network, having approximately 2 megabits per users. Every users having 2 megabits per second data rate to provide them. So that's what whenever we apply any applications online, they'll asking you, or when you are writing any exam in online, they'll say you to have a minimum speed of 2 megabits per second. Every user should have an speed of 2 megabits per second downloading or uploading, such that they write their exams well, or they upload their data very well without any errors. 2 mbps per user. So that will depend upon again on the vehicle speed. If you are in motion, or if the mobile which you're having and you're uploading is in motion, then the data rate will reduce. So the extended version of the CDMA 2000 third version is your EVDO or EVB, enhanced vehicular. This was specifically designed for vehicular, and this was deployed by Indonesia in the year 2010, which used a multi-carrier feature of the previous version, providing higher data rates per carrier. Every carrier will provide higher data rate of around 4.9 megabits per second per carrier. So in the previous we are seeing only 2 megabits per second. Here it is 4.9, and the uplink peak is around 1.8 megabits per carrier. So the reduced latency from statistical multiplexing across the channels gives us improved quality of service. Next is the LTE version long-term evolution, which comes under your fourth generation. So this LTE was launched in the North American during 2010, which was supported by Samsung. So this was deployed on both GSM and CDMA mobile operators with a peak data rate of 300 megabits per second, and the uplink was about 75 megabits per second. So these are the examples, the diagrams. Then came the LTE Advanced, which were using Android versions, or Apple, what do you say, Mac, Mac OS, Android OS. So the 4G technology was based on this ITU, or which is revised advanced process. So it had a peak data of 3 gigabits per second and uplink of 1.5 gigabits per second. It was released in as a release of 3GPP release 10. So this LTE advanced version incorporates higher order MIMO antenna 4x4 and beyond that allows multiple carriers to be bound into a single stream. Multi-carrier code division, multiple accessing. Long-term evolution is a future of your fourth generation. So, any queries? Any queries? So these are the references. Data communication by Fred Halsall. Communication networks by Alberto Garcia. Telecommunication switching by Tyagarajan Vishwanathan. Data and computer communication by William Stalling. Computer networks by Andrew Tannenberg. And in addition to this, Andrea Goldsmith is a textbook that you can follow.